Welcome back. Let's look at some examples involving the 3D coordinate system. All right, so here's our first example. We want to plot the following points in the 3D coordinate system. And we have 6 different points that we want to plot, points A, B, C, D, E, and F. We will work on each of these points one at a time and plot them in this given 3D coordinate system. And you can see that this system is made up of an x-axis, a y-axis, and a z-axis. All right, we need all 3 of those axes in order to plot points in 3 dimensions. And so let's take a look at our first point here, point A. Point A is at the coordinates 3, 3, 3. So the x-coordinate is 3, the y-coordinate is 3, and the z-coordinate is also 3. So let's work on plotting this point. The first thing that we want to do is locate where the x and y coordinates would be located in our system. And so notice that on our x-axis here, the positive numbers are coming out towards us. So positive x equals 3 is right here. And then for the y-axis, the positive numbers are on the right side here, and this is y equals positive 3. So now that we know where those two values are in this system, what we want to do is draw some parallel lines. And what I mean by that is we want to draw a line through x equals 3 that's parallel to the y-axis, and then we want to draw a line through y equals 3 that's parallel to the x-axis. And the point where those two lines meet up will be the point 3, 3. And then we will adjust for the z-coordinate as well. But for now, let's just work on the x and y coordinates. And let's start by drawing a line parallel to the y-axis through x equals 3. So that will look like this. And then we want to draw a line parallel to the x-axis through y equals 3. And so that will look like this. All right, and so these two lines intersect at this point right here. And so you can think of this point as sort of the shadow of where our point will be, because we have yet to take into account the z-coordinate, which is also 3. And so to finish plotting this point, what we need to do is move up 3 units in the z direction. But how do we plot that accurately? Well, what you can do is draw a diagonal from the origin to that intersection of these two lines, right? Draw a line like this. And then what you want to do is draw a line parallel to this line through the z value of that z-coordinate, which is 3. So let's draw a line through z equals 3 that's parallel to this line. And you can see I did that here. And our point is going to be where this line would intersect with a line coming straight up from our shadow point, if you want to call it that, where our other two lines intersected. All right, so if we move up from that point, we intersect with this line right here, and so that is where the point A would be located in this 3D coordinate system. All right, now if I erase some of these excess lines, you can start to see what point A actually looks like in 3D space. All right, it's the point 3, 3, 3. So that's point A. Now let's work on point B. Point B is at the coordinates -2, -4, -3. So unlike point A, all of the coordinates of point B are negative. All right, and so let's see what this point will look like. Once again, we want to start by looking at our x and y coordinates, which are -2 and -4. Let's identify where those values of x and y are in our coordinate system. X equals -2, that's right here. This is our x-axis, and going behind the yz plane is where the negative x values are. And so this right here is x equals -2, and then y equals -4 will be over here, right? This is our y-axis, and these are the negative y values. So -1, 2, 3, 4. This right here is y equals -4. So what we want to do, just like we did with the previous point, is draw some parallel lines. We want to draw a line through x equals 2, that's parallel to the y-axis, and then we want to draw a line through y equals -4, that's parallel to the x-axis. And so let's do that. Here's our line crossing through x equals -2, that's parallel to the y-axis. And then here's our line crossing through y equals -4, that's parallel to the x-axis. And so where those two lines intersect is where our point is located in the xy plane. However, we need to now shift it up or down along the z-axis depending on our z-coordinate. In this case, it's -3, and so we're going to be shifting down 3 units in the z direction. So from this point, we want to go down 3 units along the z-axis. And so how are we going to do that? Well, just like we did with point A, what you want to do is start by drawing a line from the origin to that point of intersection that you just found. And then you want to draw a line that is parallel to the z-axis and find that value of z that corresponds to your coordinate, -3. So that's going to be right here along our z-axis, -3. We want to draw a line parallel to this line until it meets with this straight line from our shadow point that is parallel to the z-axis. So through z equals -3, we'll draw this line. It's parallel to this line that we drew from the origin to our shadow point, and where this line meets with this straight line is where our point is located. That is point B. And now, just like we did for point A, let's remove some of these excess lines so that we can really see where point B is located. All right, so point B is at the coordinates -2, -4, -3. And so if we start at the origin, we go -2 in the x direction, -4 in the y direction, and then -3 in the z direction. And so that is point B. All right, let's move on to our next point, which is point C. And point C is located at the coordinates 5, 3, 0. So this is an interesting point. We have an x and y coordinate, but then the z coordinate is 0, and so that means that our point is not going to leave the xy plane. It doesn't move up in the z direction, and it doesn't move down in the z direction. It's going to stay at wherever these x and y coordinates are. So this is going to be a little bit easier to plot than the previous 2 points. And so let's work on this. The x coordinate is 5, and the y coordinate is 3. If we look at our coordinate system, x equals 5 is right here, and then y equals 3 is over here. So let's draw some lines that are parallel to the other axes. I'm going to start by drawing a line through x equals 5 that's parallel to the y-axis, and then I'll draw a line through y equals 3 that's parallel to the x-axis. All right, and so you can see that these two lines meet right here. And so let's draw our point right there because we don't need to move up or down in the z direction, right? Our z coordinate is 0. And so if I remove some of these excess lines here, you can see that point C is this point right here. We are at the point 5, 3, 0. Okay, so when you don't have a z coordinate, plotting points in the three-dimensional coordinate system is pretty simple. You just determine where the parallel lines would meet from your respective x and y values. All right, let's move on to point D. Point D is even simpler than point C. Point D has the coordinates 0, 0, -4. So the x-coordinate is 0, the y-coordinate is 0, and the z-coordinate is -4. And so what this tells us is that when we plot this point, we're not going to be moving anywhere in the x direction. We're not going to be moving anywhere in the y direction. We're only going to move in the z direction. So we're going to stay along the z-axis. All right, a similar thing would happen if our point was 0, -4, 0, right? If we swap those two coordinates, since the x and z coordinates are 0, that would mean that we're only moving in the y direction. So this point would stay along the y-axis. And in the same way, if we had -4, 0, 0, where we only had an x-coordinate, where the y and z coordinates are 0, this tells us that we're not moving in the y or z direction, so we'd only be moving in the x direction. This point would be along the x-axis. All right, but let's actually plot the point we have here, which is point D. It's at the coordinate 0, 0, -4. So if we start at the origin, we move 0 in the x direction, 0 in the y direction, and then -4 in the z direction. So our point's right here. All right, so this point right here at -4 along the z-axis is our point D. All right, so that was simple enough. Now let's work on point E. Point E has the coordinates 4, -2, -2. So now we're back to what we had with the first 2 points. We have a coordinate point where none of the coordinates are 0. So we have to account for the x, y, and z directions here. Our x-coordinate is 4, and our y-coordinate is -2. So let's locate those values in our coordinate system. X equals +4 is right here, and y equals -2 is right here. So let's draw some parallel lines. I'm going to draw a line through x equals 4, that's parallel to the y-axis, and then I'm going to draw a line through y equals -2, that's parallel to the x-axis. And so where those two lines meet is the shadow point for point E. All right, that's not where the point's located because we have a z-coordinate that we need to take into account. It's -2, and so we need to shift this point down 2 units in the z direction. All right, and so to do that accurately, what we should do is first draw a diagonal line from the origin to that intersection, to that shadow point. So that will look like this. And then to prepare for drawing this line from z equals -2, our coordinate, we should draw a straight line going down that's parallel to the z-axis, like this, so that we have a line that will intersect with our next line to show us how far down our point needs to go. And so now we can actually draw our final line. We want to draw a line parallel to this line, this diagonal line, that crosses through z equals -2. That corresponds to our z coordinate. So that will look like this. All right, it's not perfect, but this line right here is supposed to be parallel to this diagonal line. And so you can see that it intersects with this straight line right here. And so that is where point E is located. All right, so once again, I'm going to get rid of some of these extra lines so that we can really see where point E is. Point E is at the coordinates 4, -2, -2. So if we start at the origin, we move 4 in the x direction, -2 in the y direction, and then -2 in the z direction. So that's point E. Okay, so now we have one point left to plot, and that is point F. And point F is at the coordinates -3, 3, 4. So let's start by identifying x equals -3 and y equals +3. Starting at the origin, x equals -3 takes us back here. Remember, this is the x-axis, so that's x equals -3. And then y equals +3 takes us right here. All right, so what I'm going to do is draw a line through x equals -3 that's parallel to the y-axis. Then I'll draw another line through y equals 3 that's parallel to the x-axis. And then we'll worry about accounting for the z-coordinate. All right, so here's our first parallel line. That goes through x equals -3. It's parallel to the y-axis. And then here's our other line, which crosses through y equals +3, and it's parallel to the x-axis. All right, and now these two lines meet right here. That's their intersection point. And so since we are going to be moving up in the z direction, we have +4, I'm going to draw a line straight down to that intersection point. And this is going to help us determine where our point should be. Because now, to account for this z-coordinate, we want to start by drawing a diagonal from the origin to that shadow point. So that will look like this. And then we want to draw a line parallel to that crosses through our z-coordinate, or the value for our z-coordinate, which is 4. And so if we go to z equals 4 right here, and draw a line parallel to that other one we drew, then right here will be the point F. Okay, so if I clean up the little extra lines here, you can see that point F is located at the point -3, +3, +4, right? Those are the coordinates of point F. Okay, and so that's it. That was the last point that we needed to plot in the 3D coordinate system. Now that all of these points have been plotted, this coordinate system kind of looks like a mess, but unfortunately that is a byproduct of how we need to go about plotting these points. In order to plot them accurately in 3 dimensions on a 2-dimensional surface, things have to get messy, unfortunately. If we could actually plot points in a 3-dimensional space and didn't need to use a 2-dimensional surface such as paper or a screen like I'm using here, then this wouldn't look as messy. It would look a lot nicer, but unfortunately, this is how we have to go about plotting 3D points by hand. All right, and so that's it for this example. Let's take a look at a different one. Hey there, real quick, before we take a look at the next example, if you find my tutorial videos here at JK Math to be helpful and you want access to more content such as exclusive bonus videos and dark mode versions of my videos, I'd invite you to check out my membership site, JK Math Plus, where all of that content is available. To learn how to join and see a full list of everything you'd get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. Okay, so if you're interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's get back to the video and take a look at the next example. Okay, so now this next example is a little bit different, and the purpose of this example is to help you really visualize what the x, y, and z coordinates of a point in 3D space actually represent in terms of our 3D coordinate system. All right, and so what we want to do here is determine the coordinates of the points described below. And we have 3 different descriptions describing 3 different points that we need to determine. And so let's start with the first one here. It says the point is located 7 units in front of the YZ plane, 2 units to the left of the xz plane and 1 unit below the xy plane. So when you get a problem like this, what you want to do is first start by drawing a small three-dimensional system. All right, so I'm going to draw 3 lines. This will be the z-axis, the y-axis, and then our x-axis. Let me just quickly label them. There's the z, the x, and the y. The point in question here is located 7 units in front of the yz plane. So what does that mean? Well, the yz plane is the plane formed by the y and z axis. So the plane that is in line with those two axes. So if we have a point located 7 units in front of that plane, that means we're moving outward from that plane. That's describing an x-coordinate, right? The x-axis is perpendicular to both the y and z axis, and so it represents the distance from the yz plane. So if we are 7 units in front of the yz plane, we are 7 units in the positive x direction. All right, so we are moving 7 units that way towards the positive x direction. Then the next thing that we're told is that the point is 2 units to the left of the xz plane. So now what is the xz plane? Well, the xz plane is the plane formed by the x and z axis. And so for 2 units to the left of that plane, that is describing the y direction, right? The y-axis is perpendicular to both the z and x-axis. And so if we are moving away from that xz plane, in particular 2 units to the left of that plane, we are measuring in the y direction. All right, if we're moving to the right from the xz plane, we're moving in the positive y direction. And if we're moving to the left of the xz plane, then we're moving in the negative y direction. All right, so 2 units to the left of the xz plane tells us that our y coordinate is -2, or that we are moving 2 in that direction, left of the xz plane. All right, and then finally we have 1 unit below the xy plane. Now hopefully you know what the xy plane is. It's the plane formed by the x and y axis, so this plane right here. And the z-axis is perpendicular to both the x and y axes, right? So it's going straight through the xy plane. And so if we're measuring below the xy plane, we are measuring in the z direction. Okay, so for 1 unit below the xy plane, then we are looking at a z value of -1. We're moving 1 down in the z direction. Okay, so to summarize, the point that we're looking at here is going to be the point 7, -2, -1, right? 7 in the positive x direction, -2 in the y direction, and then -1 in the z direction. Okay, and so the takeaway here, to make these problems a lot simpler, is to think about it like this. If we're measuring from the yz plane, then we're talking about the x direction, because the x-axis is not included in the yz plane. It's going to be perpendicular to it. If you're measuring from the xz plane, then we're talking about the y direction. The xz plane does not include the y-axis. And then if we're measuring from the xy plane, we're talking about the z direction, because the z-axis is not a part of that xy plane. All right, so hopefully that makes things a little bit simpler from here on out. Let's see how that works for us with this next description. We have that the point is located on the x-axis 8 units in front of the yz plane. Now, before we do anything else, what does that last part tell us? 8 units in front of the yz plane. We just went over this. If we're measuring from the yz plane, what axis doesn't that include? The x-axis, right? The yz plane is the plane formed by the y and z axis. So this measurement that we have here must be a measurement of x. We are 8 units in front of the yz plane. So we're talking about the x direction, particularly 8 in front of it. And so that's going to be a positive x coordinate. All right, if it was behind the yz plane, then that would be a negative x coordinate. Let me just draw the coordinate system again. This is our z-axis, x-axis, y-axis. We now know that we are located 8 units in front of the yz plane. Now, the other thing we know is that our point is located on the x-axis. So what does that tell us? Well, that tells us that our point is along this axis right here, and it has no y direction and no z direction. It's just a point along the x-axis that is 8 units from the yz plane. So this is pretty simple. Our point here is just 8, 0, 0, right? We're 8 units from the yz plane, and we're along the x-axis. If you're along an axis, then only one of your coordinates will not be 0. All right, if we were along the y-axis, then the z and x coordinates would be 0, and if we're along the z-axis, then the x and y coordinates would be 0. All right, so that was a little bit of an easier one. Let's keep our xyz plane here and look at the last description. This time we're told that the point is located on the yz plane, 4 units to the right of the xz plane, and 2 units above the xy plane. All right, so let's take this down piece by piece. The first thing that we're told is that the point is located on the yz plane. So the yz plane is the plane formed by the y and z axis. So if we are on the yz plane, that means that there is no x direction. We are not measuring away from that plane. We are in the plane. So since we're on the plane and not measuring away from it, the x coordinate here will be 0. So we'll start by writing that. The x coordinate is 0, but what about the y and z coordinates? Well, that's what the rest of this description is telling us. The point is 4 units to the right of the xz plane. If we're measuring from the xz plane, then that means we're talking about the y direction. The xz plane is right here, and we're measuring away from it, either left or right, in this case to the right, and so 4 units to the right is going to be positive 4 in the y direction. All right, so our y coordinate here is 4. And then what about the z coordinate? We can assume that this last part's going to tell us what it is. We're 2 units above the xy plane, which is exactly how you would measure the z coordinate. When you're measuring in the z direction, you are measuring from the xy plane. In this case, we are above the xy plane by 2 units, so our z coordinate will be positive 2. All right, so that's going to be our last coordinate, and that's the point described by this description. All right, so that's it for this example. Hopefully this helps you understand what the x, y, and z coordinates are and how we measure them. Really, each of those coordinates are just measurements from different planes within the coordinate system. The x coordinate is measured from the yz plane, the y coordinates are measured from the xz plane, and the z coordinates are measured from the xy plane. Okay, and so with that, that's it for this video. If you want to see some more examples, I do have more available on my membership site, so feel free to look into becoming a member if that interests you. If you have any questions, feel free to leave those in the comments, but if you don't have any questions, this is all I had for now, so I will see you next time.